Okay, so we should be able to go now. Okay, the topic today is Introduction to Arrays. This is something I talked about recently. We recently had a user conference here in Seattle. That was at the end of September. And this is something I talked about in that user conference. I also talked about, in the same session, I talked about using the script element. And I actually didn't end up having enough time really to get everything in, and there were also people that couldn't. There were parallel tracks at the user conference of classes, and so people could not attend everything, and so we decided to do webinars of what we just redid our. We're redoing our basically our presentations, but as webinars, and we're doing recordings of them, and we'll post those on our website. So let me actually just take a moment to show you where our webinars are, in case you don't already know. So if you go to our website and go to resources, right here, over on the left-hand side, there's webinars. And there's this is showing us the current one. Future webinars are right here, and these are all things that were talked about at the user conference, and so these are all yet future webinars, but we'll do recordings of those, and those will be made available. You can also take a look at past webinars here. We have a long list of past webinars. Okay, so an overview of what I'm going to talk about today. It's basically 3 sections. I'm just going to introduce the topic with various examples, and we'll actually spend a fair amount of time on this, even though this is meant to be an introduction section. We'll look at some examples, and as we look at the examples, we'll touch on certain aspects of using vectors, or using arrays, which are vectors and matrices, in GoldSim, and you'll actually pick up a fair amount of information in just the introductory section. And then we'll go into some array basics, which we will have already talked about, some of them at least, in the introduction section, but we'll just touch upon some other things that I may not have mentioned yet in the introductory section. Then we'll move into the last section, which is advanced arrays. We'll talk about something called array constructors, and there are 2 types of array constructors, and that's just the vector constructor and the matrix constructor. And if you haven't heard of these, hopefully you've at least heard of them, but even if you have heard of them, I'd encourage you to take a look at the help in GoldSim. So I'm just going to open up GoldSim, the latest version here, but it doesn't matter what version. This was implemented as of 10.5, I think, these array constructors. So if you go to help and then help topics, and then do a search here for array constructor, and then I think this first one here actually is an article you could start with, defining arrays in an input field using array constructors. So that's probably something that you'll want to take a look at, because array constructors are I think one of the most useful things, and maybe possibly underused things in GoldSim for how useful they are. And so we'll talk about that in the 3rd section. Okay, so arrays are basically just collections of data, either in a kind of a one-dimensional format like a list. So I'm going to show you an example in a minute of a vector of populations of cities. There's also matrices which have rows and columns. So, and we'll look at an example where the rows are populations in cities, but then the columns, the populations are broken out into male and female populations. So we'll take a look at what these look like in GoldSim. Vectors or arrays are supported in some form or another by most of the GoldSim elements. And so there's a lot that you can do with them. And in fact, if you're using contaminant transport, you more or less have to use arrays because you define species in the species element when you use the CT module, and then you need to use those throughout the model. We'll talk about referencing subitems, both single items in a vector or matrix, and also in the case of matrices, you can reference entire rows or columns at a time. And then we'll just look at a few examples here, a simple reservoir example, AWBM watershed model, that's in our model library, and when we get to that, I'll show you where you can find that on our website. And then this example here, monthly and yearly cumulative flows, that's the one that I've created specifically to teach array, or to illustrate how powerful array constructors can be. So like I said, we're just looking at either lists of values or kind of a matrix of values with rows and columns. So I mentioned this example of populations of cities. These happen to be 3 major cities here in Western Washington. And this is a data element, and we'll go and look at that in GoldSim. We'll open up GoldSim in just a moment. Here's an example of a matrix. This is just looking at the tooltip, but you can see that this has rows and columns, cities by group, and by group I mean male and female. So let me just open up GoldSim. Well, it's actually already open, but let me just open up a model that we'll look at here. Okay, so here we have those 2 data elements. Let me actually just start out by creating a scalar data element. And for a scalar data element, we just have this single field. But as soon as you convert it to a vector or matrix, this disappears, and we'll have a little edit button over here. So let me just do that real quick. So you can do that by going to type. Right now you see that it's a scalar, but we're going to change that by going to type. And then order, we have scalar, vector, matrix. Let's just make a vector. And then you have to select an array label set. And you saw in my example just a minute ago that I had those names of cities, Seattle, Tacoma, and Olympia. So I actually defined those in an array label set, and I'll show you later how to create array label sets. But we're just going to use one of the ones that's already there. Let's just go ahead and do city. As soon as I do this, then this changes to vector square brackets city, and that city is the name of the array label set. And then in here we can enter our values. And these fields here just operate just like the input field in an expression element. So I could actually put 1 + 5, or I could actually reference another. If I had another element, say a scalar element here in this model, I could reference it here. So again, you can just put in anything you want, or any sort of expression in there, complex expression, including things like, here's a built-in function, square root of 5, things like that. So nothing complicated there. And if we want to make this a matrix, then that'll activate this drop list here, and then we can select group. And now we have our cities here, and then male and female populations there. Okay, so next thing is, how do we reference items in these arrays? I'm going to create an expression element, but we could create any number of other elements here. Say well, let's do like a reservoir element. And I could put, for my initial value, I could actually reference one of these. And so you can do this in input fields for most of the elements, or we can do it in an expression element. I'm just going to cancel out of this, and we're just going to do a basic expression element. Okay, so all you do here is you just reference the name of the vector element or the matrix element. So I'm going to do populations underscore vector. Okay, so this is invalid because this expression element is a scalar and we have a vector here. So we're going to reference just one item in that vector. So we do that with an opening square bracket. And here I'm just going to type the name of one of those cities. So I'll do Tacoma in this case, and then a closing square bracket, and that gets you the population then for Tacoma. I could have done this differently. I could have actually referenced this by index. And in GoldSim, we index starting with 1. So 1 would actually be the first item in that population vector. That's for the one for Seattle. So that's 650,000. If I put in Seattle, that would give us the same thing. Okay, so now what if we want to do reference an item in the populations matrix here, this matrix data element. Similar thing, except we're going to specify one of the labels from the rows and one of the labels from the columns. So let's say Seattle, comma, and then let's reference the female population, closing square bracket, and that's the population of the female population of Seattle. Okay, and so that's again, these are just the kind of the basic nuts and bolts. We're going to get into some things that are more interesting, but here's one thing that's a little bit more interesting. Let's say I want to pull out a full, let's say just the male population of all those cities. So this is going to generate a vector. So I'm actually going to have to select vector, and then my array label set is going to be city. So now what we can do is I can reference the populations matrix, and then what I'm going to do is I want all the rows for just the male column, the first column. So I'm just going to put an asterisk in, a star, and that means all rows in the, and then I'm going to type male in the male column, and there you go. There's the male populations for Seattle, Tacoma, and Olympia. So, and you can do something similar, but just putting the asterisk in the second, for the second field, and say get the male and female populations just for Seattle. But then we'd have to change our array label set to groups. But we'll leave it at that. Okay, let me just, we talked about, okay, yeah, one more thing I wanted to mention on this. Okay, so GoldSim, I'm gonna keep this as a vector of cities. I'm gonna delete this out for now. And what we're gonna do here is, what if we want to know, what if we don't have this total populations vector? So that's the total populations for each of our 3 cities. What if I only have this populations matrix broken out so that they're broken out into the male and female populations? Well, there's several built-in matrix function or array functions in GoldSim, and one of those is exactly what we need to do this. So I'm going to right-click in here, and I'm going to go, we have a lot of built-in functions here. And if you haven't looked at these before, just take a look through these at some point on your own time and just see what all there is here. But there's a lot in here. And if you look at the array operators, there's a long list here. It actually extends down. Oh, maybe it doesn't, but anyway, the one we want is this, let's see, is this sum R, S-U-M-R. So we're going to sum items in each row. The reason it says or here is because we could also have a matrix of Boolean values, in other words, true and false values. And this operates like an or across the rows. But in this case, we just have regular numerical values. So we're just going to sum, we're going to add up across each row the total populations for each of the 3 cities. So I'm going to insert this, and I'm going to put in our populations matrix. And right there you can see the total populations for our 3 cities. So this combines the male and female populations. It automatically adds them together. And this right here in the tooltip is, of course, what we have already right here. But this just gives you, I just want to make sure you know about these built-in array operators, and you should take a look at them. Okay, so let's go on to our examples. I'm going to open up this basic reservoir model. And in this example, we have 3 reservoirs, and each of those has 3 inputs. One for the inflow rate of, it could be water, inflow rate of water. Fractional outflow, so the way I've set this up is that imagining this to just be a pond, the outflow is a function, is some fraction of the reservoir volume, and then I've specified an upper bound. And I've done this for all 3 of our reservoirs, as you can see here. Each of these, the withdrawal from reservoir A goes into B, and then from B into C, but each one of these has an overflow that's added up here and goes into this overflow reservoir. What I want to do here is, instead of having all 9 of these separate elements, I'm going to combine those, and I'm going to show you this new example. Oop, I selected the wrong one. Okay. Oh, whoops. I saved it from when I did this morning. That's okay though. I'm going to temporarily move these up to the top level of the model where they were originally. And actually it's too bad that this happened because sorry about this. I'm just going to delete some stuff out here. You're seeing in reverse order what I'm going to do in a moment in forward. Let's see. Okay, so you just saw a preview in reverse order, but what I've done is I've combined those inputs into just these 3 elements. And so here I have a vector for the upper bound, and those are the upper bounds for each of the 3 reservoirs. Similar thing here, and then for the time series, those are actually 3 separate columns of data. So one nice thing about this is that we can then take our inputs and we can put them into a grid input. Here's a grid input. I don't know how much you've used dashboards, but we can create an input grid and then select vector type data elements, and then we can select these, and they'll I can't reselect them because they're already in the grid here, but we can select these and they will appear in this grid, and then we can just input our values directly through here. So I could just edit these and then run the model and look at our results. And here's our 3 reservoirs. So the little demonstration I wanted to do here is now that we've put these into a vector format like this, what if we now want to add another reservoir, say reservoir D? Well, the first thing we'd need to do, and this is just to illustrate how easy it is to basically scale up a model like this with the when you're using vectors like this. I'm going to go to the array label set, and that's in Model, Array Labels, and I'm just going to click on there and click Edit, and then I'm going to add an item here, and I'm going to call it D. Okay, so how does this affect our model? Well, first of all, if we look here, now we need to specify values here for D. So I'm going to put those values in, and but that's just one part of what we need to do. So that takes care of this and this. We now have our inputs for reservoir D, but here now we have this extra column for D that for now I'm just going to select this whole column, copy. I did a Control C and then select the first cell there, and I just do a Control V, and I just paste that data in. So we've modified the inputs. Now let's create our extra reservoir, or our new reservoir. So I'm gonna rename this to Reservoir D, and you can actually just directly edit this label. I'm just going to hold down Control and double click this, and that allows me to edit this. So there's Reservoir D. Now I'm going to go into it, and all we have to do is edit what item is being referenced in each of these inputs. So we want to reference item D, so I'll modify all of those. And then I'm going to change this to Reservoir D. And then I'm just going to say that Reservoir D receives an outflow from Reservoir C. And that's it. That's about all we need to do. We can add our overflow here. Overflow. And we can add Reservoir D to this. And then we can go back into our dashboard, run our model, and look at our results. And there's our new reservoir right there. So that wasn't very hard. And so even once you've defined your vectors, you can still go in and you can edit these array label sets. One thing I'll show you right here also, actually we're in result mode, so here's one thing that you can do as well. So all I did was I could have selected it and then clicked edit set, or you can just double click this and it'll allow you to edit this. So I can actually move these around. Let's say this isn't the order we want them in. I have them in alphabetical order, so it looks like a good order, but you know, it may be that you have a situation where you do want to rearrange these. So I can move these up, and it doesn't matter so long as throughout my model. So you see already that it rearranged this, reordered this. There's D with 6 and 65, which is what we specified earlier for it. Another thing is that because these all referenced by the names, by the labels, these still reference the correct values, even though we rearranged the order. Now what would not have worked is, imagine if I had originally put in a 4 here. You remember I said you can reference by index. If I'd put in 4 and then rearranged, this would still be referencing the wrong value. So that's one of the advantages of using what's called a named array label set, like we created. So that's something to keep in mind. Okay, so let's move on to the next example, and that's this AWBM model. Okay, and I'm just going to show you real quick where you can find this. I'm just opening our website, or I'm just going to go to the home page. If you haven't been to our model library, just go to our main homepage here, goldsim.com, and then go to library. And then in our library, we actually have a model library, a knowledge base, and an image library. So we want to go to the model library. And this is divided into these different categories. You can expand them out and browse through here. We can do a search here for AWBM. And here we have two results. I'm just going to open these up in new tabs. And you can read through this. This is a popular runoff model in Australia. You can see that here. It's a widely used rainfall runoff model. And here's a schematic. We don't have to go into detail on this, but this is just for one, say you're just modeling one catchment here. It's actually modeled as three separate components. And in the example we're going to look at here first, this is going to be modeled as a vector reservoir element. And then that's all collected together because this is all just from one area, and it's going to be split into these two contributions to runoff, base flow and surface runoff. So coming back to this example, so we can hover over this and you see that this is the name of the reservoir element is surface underscore stores, but there's also this array label set called surface stores. And that's those three parts, three components of this catchment here. And so that's what that corresponds to. And here we split we actually, look at this, we sum together the overflow rates here using sum V. So now we just have a scalar value that goes into this splitter, and it splits it out into a surface runoff component and a base flow component, and those are just scalars. But in this next example, the other one that we saw here in our results, and you can just take a look at this as well. Here, the watershed is divided into 7 subbasins. So in this case, let me just open it up. It's going to look very similar, but this time this is a matrix where those surface stores we saw originally are the rows, and then the columns are catchments. We have a more complex way of splitting that because GoldSim doesn't support a vector splitter, and so this uses a looping container to go through each of the 7 catchments and get the base flow and surface runoff for each of those. So these actually are vectors. A vector. These are vectors of catchments. And then we sum them together here to get total runoff, and we can actually run this model. And here we have our different area 1, 2, 3 through 7 right there. So yeah, take a look at that. That's as much detail as we're going to go into on this for this webinar, but take a look at those if those interest you. Now we're going to move on to the last example, and this is going to remain the focus of the remainder of the webinar. So in GoldSim, if you haven't, another thing you may want to look up and read up on is reporting periods in GoldSim. So if you open up GoldSim and you go to the time settings, I'm just going to click, I'm going to press F2, that'll open the time settings. And you come down here to the bottom half, you see reporting steps. I've defined major and minor reporting periods. You see here I have a daily time step in this model, but I've defined reporting periods on a monthly basis and on an annual basis. What this allows us to do then, I'm going to run this model, and I'm just going to open up this result element, and let me just explain to you something real quick before we look at that. This right here is just a stochastic that resamples on every time step, so on a daily basis, and this could be flow, the rain, water flow, and if you look at that, you see it has some stochasticity. It bounces around, and again, like I said, this is on a daily time basis. But what we can do with reporting periods is take that and convert it or calculate from that certain quantities over each period. So in this case, it's a monthly period. And what I've done in this time history element is for the time display setting, I've specified reporting periods. And I can't change this right now because I'm in result mode. But I've specified reporting periods, and then I've connected this stochastic here twice. One just shows basically the raw data of the flow data on a daily basis. But here, what I've done is I've specified, if I were, let me just actually for a moment go into edit mode. You see that these are drop lists, and for a reporting period, I can say, okay, I want the cumulative, and that's going to act as like an integrator. It's going to integrate those flows over time, and that's going to give us volumes. So the value for a given month is how much water accumulated during that period of time, the volume of water that accumulated. We can do average over that time period, the change over that time period, but we're going to stick with just cumulative right now. And I'm going to run this, and what we get when we excuse me, when we look at this is, instead of our daily time steps over here, we have each of the months of our model. So here's for 2015, and each one of these is just these are volumes. This is the total amount of water that accumulated. And so the thing about this is that these are just results, and so you can only view them. You can't do subsequent calculations with them because it's the result element itself that's doing these calculations, and of course we can't link elements to the a result element doesn't have an output, so you can't link to that and get those values. So what if you do want to use those values for subsequent calculations? For example, what if you have monthly totals and you wanted to be able to calculate the yearly totals for each of the years, or you wanted to calculate the maximum value of, say, a 12-month period of time? You want to get the one that's the maximum in that 1 year. Well, to do that, we can take a different approach, and we're going to use vector constructors for that. So we'll come back to this in a little while, but I just want to, you don't have to understand this quite yet, but what I have here is one vector that stores the year for each month of the simulation. So the first 12 months of the simulation are each 2015. The next 12 are 2016, and the last 12 are 2017. And we're going to use that in this container here. Here's this part I think is very interesting. What we're doing here is, this is a vector integrator by month, and it's 36 items long. So that's the 36 months in our simulation. And because this is a vector integrator, we need this to be a vector rate of change. But what we want to do here is construct that vector, that rate of change vector, such that it's all zeros except in the month that we're currently in the simulation. So say we're in the 10th month of the simulation, we only want the 10th value in this vector to be changing. We are accumulating. And so we're going to set all the rates to 0 except for the rate at that index that corresponds to the month that we're in. And if we do that, and we'll talk about how this works later, because we use this keyword, this row keyword. I'll talk about that a little bit later. But what we get here now is these are the integrated monthly totals. And I've only plotted months 1, 4, 7, and 10. And you notice that starting here, the only one that's increasing is for January. These are all January right here. So that's the only one that's changing. These ones are not changing. If I look at the chart, we see that the monthly total for 1 is increasing over the course of January, and then it just stops increasing. This one for month 4 is increasing in April and then just stops at the end of April. And what we have down at the end then, if we look back in the table view and we scroll down, is we have monthly totals. So let me just show you now. Let's compare. This is the full vector of those monthly totals. These are the ones we calculated using this integrator. This one right here is the one that we got from using reporting periods. We can put them side by side and see that they're the exact same thing. So we've basically done what GoldSim, what the time history element was doing. We've done it in a different way, but we've accomplished the same thing. And then what we can do in here is again use a vector constructor. But again, we're going to use this row keyword. And again, we're going to talk about this in just a moment, how this works. But what this accomplishes here is that this vector we construct here, it's 36 items long for our 36 months, but only the first 12 are non-zero. So what we've gotten here, we've pulled out just the monthly totals only for 2015 and set all the others to 0. Well, what does that buy us? Well, as we talked about before, we talked about these built-in array functions. We can use one of those. For example, here I use sumv. We already saw. I don't know if we saw sumv before. We saw sumr, but sumv means sum vector. So add up over a vector. And I'm referencing monthly totals 2015. And you see in the tooltip 31.1779. Let's just make sure that that's correct. So here I have yearly totals calculated using reporting periods. And that first one is 31.1779. 2016 is, let's see, with reporting periods, we got 28.86. Come back in here, we got 28.86. So now, if you want to know how we did that, how these vector constructors work with, first of all, an if statement in here, and then we're referencing a couple of elements here, and we're also using this keyword row, and there's also another one called call, C-O-L, and you can use that when you're doing these sorts of operations. You can use them inside of you can use row and call inside of a matrix constructor. You can use row inside of a vector constructor, and GoldSim knows what that means. So let me just skip ahead in my notes here. Let me just touch on that. That was our introductory section, but that's okay because we've talked about a lot of array related things. This is going to be very brief. And also the example we just saw is the example we're going to actually end on. We're going to end by looking in detail at how that works. But just so you know, just some basics that we didn't touch on yet. If you have, say, a vector, let me just make this a little bigger, sorry. Both of these are vectors, these data elements, A and B. They're both vectors. Now, this expression element is also a vector, and it has to be, since we're operating on, what we're doing here is we're going to do some basic arithmetic, just adding, multiplying with these. And you can see here, all I've entered here is A plus 10 times B. And like I said, A is a vector, B is a vector, and so you can operate, you can include these in expressions just like you would a scalar value. And as long as you have defined your element where you're doing the calculation, in this case it's an expression element, as long as you've defined that as a vector, then that'll be valid. And in this case it's a vector of days. So you can do all sorts of calculations just like you would with scalars. I briefly mentioned array label sets, and I'll just show you a couple more things about array label sets. Okay, so I'm just going to put this in edit mode. If I go in here to model array labels, there's two. If you go to add new set, and I think I already might have mentioned this, but we have two types of array label sets. Named, which is what you've seen, where I specified the names of cities, or I specified male and female. So there's named array label sets, and you can just, we've already seen this, you can add items in there, A, B, C, like that. Let's add another one and have this one be an indexed set. And here all you do is you specify a range. So let's see, if I put in a 5 here and I tab out, then that populates this with values 1 through 5. 1 through 5. You can also specify a 0 here, and you can have an index starting with 0. That might be useful in some cases. And alternatively, you could put in 3, tab out of that, and you can actually have indexes 3, 4, and 5. So there's some flexibility there. Yeah, okay, so let's go into talking about vector constructors. And you've seen some, and at a very basic level, a vector constructor, if I just create an expression element here, and I say that this is a vector of set 1, that's the named array label set that we just created. I can actually just put in the keyword vector, opening parenthesis, and then let's say values 2, 4, 6. And there you go, you've just constructed a vector in an expression element. And you could do this same thing inside of an input field for a vector integrator, or any number of other elements, because most of the elements in GoldSim support vectors and arrays in general, vectors and matrices in some form or another. An exception would be the event, like triggered event, timed event, discrete changes, status element, those sorts of things. Okay, another thing we can do in here, what if all we do is we just put in a 2? Well, this will just populate the whole vector with just that value. So you can imagine something like this, where we have, let me just do this real quick. A data element, I'm going to call it A, and I'm going to make this a vector. And I'm going to just put in values 2, 4, 6. But now in here we could reference A like that, but we could also do this. If we just wanted to put in, we just wanted to add 1 to every item in that vector, we could just do vector 1 like that. And this term right here by itself is just a vector of 1s, and that gets added to A to get 3, 5, and 7. Okay, okay, so now let me show you another thing. And I'm going to introduce now the row keyword. What if we just did vector, and I told you that the row keyword, GoldSim can interpret that when it appears inside of a vector constructor or a matrix constructor. And if I close that, then all this does is it loads it up with values 1, 2, and 3. So row always corresponds to whatever index you happen to be, whatever item you happen to be on. Say, you can imagine as this vector is being created, If you went sequentially through item 1, the value for that the value of row at item 1 would be 1, and so it loads in a value of 1. At row 2, it's a value of 2, and so we could also do something like this. Let me give this units of meters, and we can put this in an expression. So row times 1 meter, or let's say row times 2 meters, 2, 4, and 6. And so basically row just always corresponds to the row number or index in the vector. And so I've actually got a schematic for this. And so right here, we step through. If we come down here to the second item in this vector, row equals 2 at that point, and so we take 2 times 1 meter to get 2 meters. There's other possibilities here. What if inside the vector constructor we referenced another element? In this case, this element called vector 1, and we put in row inside the square brackets. What that does is, say we're down here on, we're populating A, we're creating A, using this expression here. At row 3, row has a value of 3, so what it does is it pulls the third item out of vector 1 and loads it in to vector A. Well, this is of limited value because we could have, without the vector constructor, just directly referenced vector 1 and it would have accomplished the same thing. But what if we include an if statement inside of the vector constructor? So inside of the vector constructor we say if the row is less than 3, then just load in a value of 0. Otherwise, pull in a value from this other vector. So here we're going down, and if row is less than 3, 1 and 2, then we just load in this 0 value. If it's 3 or greater, then we pull in a value from this other vector. And that's basically what I was doing in the example that you saw earlier. And so we'll go into that example now. So you remember that we calculated this using reporting periods, but we also did our own calculations using expression elements. And so let's open that up. And hopefully you have a few more minutes. We started a bit late because of the issues we had at first, but sorry about starting so late. But hopefully you can stick around. I'll just keep going, and I'll try to wrap up fairly soon. If you do have any questions, just click you can chat it to me, or click the raise your hand button, and I can unmute you, and you can ask the question. Let me just make sure that I didn't miss a question. Okay, we're okay. So let's go back to GoldSim, and let's go up to the top. So I explained this earlier. So what we get here is that this is a vector of 36 items corresponding to the 36 months in our simulation. We need a vector rate of change, and you notice here that I specified for the initial value you also need a vector, but all I've done here is just done a vector 0 liters, and that loads it up. That specifies a vector of zeros for the initial values. But here, what we do is I have an element in the model that whose value always corresponds to the index value of the current month we're in the simulation. So as we're moving through the simulation, through January 2015, it has a value of 1. Through January 2016, it has a value of 13. February 2016, it has a value of 14, so on. So this, over the course of the simulation, month count starts out at 1 and increments in a stepwise way, because it stays 1 over the whole first month, and then it steps up to 2, and then it'll keep stepping up to 36. And so at any given time, we can reference this month count. And so when we create for a given time step, say we're in month 3, and we're at a time step that's in month 3, then as we're populating this vector on that time step, just that one time step, we're going to generate this vector of rates. And we're going to, if for items 1 and 2, for row items 1 and 2, those do not equal the current month count, which is 3. So we're going to fall into this else, and so the first 2 items in that vector are going to be 0 liters per second. But for the third item, that does equal the month count, and so that's going to get our flow value. And so that's how we construct, and this constructs a new vector on each time step, because flow actually changes. Oh, no. Yeah, okay, well, anyway, for a given month, say month 3, we're going to have a vector of all zeros except for that third value is always going to be our flow. And that's how we ended up with a scenario like this. And what that got us was that now at the end of our simulation, we have all these values for the full 36 months. And then that's, and we saw this before, but let's just look at it now in a little bit of detail. Now, what we're doing, as you recall, if you recall, we're generating a vector in this case that's only non-zero for 2015 months that are in 2015. All the rest are 0. And so what we're doing here is that in that year vector, you recall that that's the first 12 values are 2015, the next 12 are 2016. And the last 12 are 2017. So only in this case, we're only going to load a non-zero value if the year vector at our current row index is equal to 2015. And we're going to grab our monthly totals. That's our integrator. We're going to grab the value out of that and load it into this vector. And that's how we got something like that. There's more that we can do than just the year total. Let's say I'm just going to copy and paste this. I just did a Control-C, Control-V, and we're going to call this year max. And we're going to put in, instead of our sum-v, S-U-M-V, we're going to use a different vector function. We're going to do max v, M-A-X-V, and that gives us, what does it give us? 3.076. That should be our maximum monthly total in the year 2015. So let's take a look at this after I run it. And is that correct? If we look at these values, the maximum is at 3.076. So there's all sorts of other stuff we could do. Those are just 2 examples, but now using vector constructors, we did what otherwise we could only get using reporting periods with our, using our time history elements to calculate reporting period totals. And by the way, using that approach anyway, we wouldn't be able to get maxes. That's not one of the options in a time history element for reporting periods. There's cumulative totals, there's averages, but not a max. And so this allowed us to do some additional things and additional calculations. So I think that is more or less it. I included a schematic here that I will post within the next, well, if I don't get to it tomorrow, I'll post it probably early next week on our website. Under the webinars, you can find, I've recorded this and I can post the video. I can post these PowerPoint slides, and I can also post a zip file of the model files, example files that I used for this. All that will be available, and you may just want to look through these slides. For example, here I show a schematic. If what I was talking about earlier didn't make much sense, this might help. make it a little bit clearer. So take a look at that. We did that, and at this point I can take questions if you have any.